All right, today and this week we're going to be talking about bisectors of triangles. And we're going to start with a perpendicular bisector theorem. And what it says is that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Perpendicular bisector. So what that would look like is if you were to have a segment, and we got segment AB, and then it was bisected by another segment, CD, and if AB is bisected by CD, then the distance from A to E is the same as the distance from E to B. If you see that diagram, then CD cuts AB in half. It bisects it. If this symbol is added to the diagram, the 90-degree symbol, now it means that CD is a perpendicular bisector of AB. Okay? CD is the symbol for perpendicular bisector of AB. It intersects it at 90 degrees and it cuts it in half. What the theorem says is if a point is on the perpendicular bisector, that means any point that's on CD is equal distance from the endpoints of the segment. So point C is right here. It's on CD. It's on the perpendicular bisector. What that means, what this rule means, is that this distance from C to A is the same as the distance from C to B. Those two segments are congruent. Any point on CD, any point on CD is the same distance from A and B. So if there was another point right here, point F, it's on a perpendicular bisector. That means F to A would be the same distance as F to B. These two distances would be the same. Any point on CD, since it's a perpendicular bisector, any point on CD is the same distance from A as it is to B. The converse of that theorem says that if a point is the same distance from the endpoints of a segment, then it is on a perpendicular bisector. So let's say you have to find AB, and you're given this picture. This angle is 90. These two distances are the same. Here's point A. And A to D is 4.1. And you need to find A to B. So since A is on the perpendicular bisector of segment BD, then A is the same distance from B as it is from D. So how far is it from A to B? That's 4.1. If you had to find W to Y, and you were given this picture, if you're looking at this diagram, do you see how this point up here, point X, is the same distance to the endpoints of a segment? X is 9 units from W, and X is also 9 units from Z. And X to Y is perpendicular to WZ. That makes XY a perpendicular bisector. You have a point on a line, and the point is the same distance from the endpoints of the segment. So it means these pieces are congruent to each other, right here and here. So how far is it from W to Y? How far? W to Y. Very good, 3 units. If we go back to, oh, let's just draw another one. You need this diagram again right here, this first one. You need that diagram again. And now you're told that A to B is 2x plus 3. And A to D is 4x minus 7. And you need to find the distance from A to B. All right, so now you've got two segments. You've got point A that's sitting on a perpendicular bisector. What that means is that your 2x plus 3 is equal to the 4x minus 7. So you can subtract 2x from each side. 3 would equal 2x minus 7. Add 7 to each side. So 10 would equal 2x, and you could divide by 2. So 5 is equal to x. If 5 is equal to x and you need to find the distance from A to B, well, AB will equal 2 times 5 plus 3. So AB will be equal to 13. All right, we're going to say here that when 3 or more lines intersect at a common point, the point is referred to as a point of concurrency. point of concurrency, where three or more points, or where three or more lines intersect each other. Three or more lines intersect at a point of concurrency. The perpendicular bisectors of a triangle are concurrent at the circumcenter. Which is equal distance from the vertices of the triangle. All right, angle bisector theorem. If a point is on the bisector of an angle, then it is the same distance from the sides of an angle, or of the angle. If a point is on the bisector of an angle, then it is the same distance from the sides of the angle. And what that picture looks like is, if you have an angle, and we got angle ABC, and if you put your pencil on point B and you try, or you draw a ray coming out of B that splits this angle in half, put point D on it. If these two angles, if angle ABD is congruent to angle DBC, if those two angles are congruent, then BD is an angle bisector, and the distance from D to BC and D to AB, those two distances are the same. The converse is also true. If a point is the same distance the sides of an angle, then it is on the angle bisector. So if you see a point on a ray and the point is the same distance from the sides of the angle, then you know that the two angles that the ray formed are congruent to each other. If a ray splits a big angle in half, all right, if BD splits this big angle ABC into two congruent pieces, then D is the same distance from the sides. You just have to know the theorem both directions. The theorem and the converse of the theorem. So if you're given this picture and you're told that A to D is 3x plus 5 and D to BC is 6x minus 7, and you have to find the distance from, let's say, D to E, you'd have to solve for x first and then substitute. So if you had to find DE, all right, your 3x plus 5 is equal to your 6x minus 7. Could subtract 3x from each side. 5 would be equal to 3x minus 7. You could add 7. So 12 would equal 3x, and then you could divide by 3. So 4 would equal x. If x is equal to 4 and you need D to E, then you substitute your 4 into the expression that represents DE. So 6 times 4 minus 7. So that's 24 minus 7, 17. Fascinating, huh? Another one of those Mondays. The angle bisectors of a triangle are concurrent at the incenter. Which is equal distance from the sides of the triangle. Any questions on angle bisectors or perpendicular bisectors? All right, then your assignment for today is going to be on page 329 and 330. One through 14. And then 21, nope, check that, 1 through 14, and then 21 to 30. Be sure to check focus for homework sometime after school today. E-learners, your pages for this week, your practice pages this week have been uploaded to the resources tab. You brick and mortars, Jenna's going to give you your handout for the week. So at this time, you guys are excused from the meeting. If you want to log out and or sign out or exit and go get your assignment finished. Yes. It's right here.